All right, let's get going. This is the walkthrough of the video that was assigned, of the AP Classroom to FRQs assigned on April 8th. Today's April 9th. So let's start by looking at the question. And we'll go like this. I'm going to do that. And then we're going to go over and find this, the one assigned on April 8th, and pull it up and take a look at it. So no calculator. You'll be able to use a 4-function calculator on the AP exam. You just won't be able to use a whiz-bang wonder calculator. All right, so we have these two figures that are going to be the things for this problem. We got a graph, and we got the table of values for selected values x and f of x. And if you check, you can see the graph does in fact match. F of 3 is about 1.65. F of 5 is 1. F of 4 is at about 2.5. Excuse me. So the graph does match. They're not trying to be too tricky, although you're going to see in a moment they are getting a little tricky. The graph of the function f and the table of selected values f of x are shown above. The graph of f has a horizontal tangent line at x equals 2. That's a piece of information we might need. It is concave up for 0 is greater than, x is greater than 0 and less than 5. So 5 is not included in that domain. The range there, I mean. Domain, I mean. Sorry, it's late in the day. And it's linear for x is greater than or equal to 5. So that matches the graph right there. Linear starting at x is greater than or equal to 5. So that's a line. Question A says approximate the value of f prime of 4.5 using the data from the table. Show the computations that lead to your answer. So here's the first trick, and I will tell you this. The trick caught me. It says use data from the table, not the graph. And this is what caught me, because I'm like, oh, well, I know I can do the limit of limit as x approaches 5, right? I know where that goes. So I would the best estimate would be probably f of 4, and the average of f of 4 and f of 5 would give me the best estimate of 4.5. But it says use data from the table. So you can't use the graph, which means to estimate the slope, right? That's the derivative of the graph at 4.5. Your best estimate using data from the table is going to just be, oh, I can't do it. Maybe, can you see that on there? You can. Okay, good. The best estimate from the table is going to be using f of 4 and f of 4.5. So let's go back to the document and we will do that. So the estimating the derivative at 4.5 is just going to be the slope at 4.5, right? And then the nearest pieces of the table we have are f of 4.5 and f of 4. So we're going to have to say that that's going to be delta y over delta x, right? You can think of it that way if you want, or you can bypass that if you don't want to. So then we're going to have f of 4.5 minus f of 4 over 4.5 minus 4. So that's going to give us, from the table, f of 4.5 is 3.193 minus f of 4 is 2.533 over 4.5 minus 4 is 0.5. And if we do all that out, we're going to get 1.320. So that is the That is the answer to the first question. That is the approximate value. So if you wanted to get the approximate value of f of 4.5 is 1.320. And like I said, I did it wrong the first time because you can't use the limit. Visually, you can see what's happening as x approaches 5. But you're not allowed to use it because the instructions say from the table. All right, so that's A. B goes like this. Let's take a look at B. B says, is there a value x, is there a value x for x between 0 and 5 such that the limit as h approaches 0 of f of x plus h minus f of x over h equals 0? Give a reason for your answer. So that's basically where f prime is going to equal 0, right? Where the limit of that approaches 0 is going to be the derivative equals 0. And we already know where the derivative equals 0. It's where the slope is 0. And we remember that the slope is 0 right here because f has a horizontal tangent. We didn't even need the graph. I almost think in this the graph is a little bit the graph misleads you in a way in this. So f has a horizontal tangent line at 2, so it's got a horizontal tangent right there, which means at that point the slope is 0, which means that is the place, that is the x, such that the limit of this deal becomes 0. So the answer to that, you can just say you can write something like this because you need to justify what you're doing. F of x plus h minus f of x over h equals, it's the same, that's right. And then you can say f of x equals 0, where f of x has, and you can write however this you want, has a tangent line with the slope equal to 0, and the problem is given. So however you want to write that, the problem setup, however you want to say it, includes the information that a horizontal tangent. Now that I do this, I'm thinking of Yusuf making fun of Saul Khan when he writes and he talks while he's writing. Horizontal tangent at x equals 2, therefore the limit as x approaches 0, f of x plus h minus f of x over h equals 0 at, that wasn't the word at, that was f, which isn't a word, at x equals 2. So that's B. All right. Oh my goodness. I did not even have that on the camera. So let me back that up. I'm not going to back it up. I'm just going to go like this and say, okay, so, well, and there's really, nothing. There's no calculations needed to follow, right? That's equivalent to the derivative, because that's what we're doing, right? The limit as h approaches 0. And so f prime of x equals 0, where f of x has a tangent with a slope equal to 0. The problem setup includes the information that a horizontal tangent is at x equals 2. Therefore, the limit as x approaches 0 of this bit equals 0 at x equals 2. That's just a given in the problem. All right, now I'm going to see if I can remember to do this. Back to the problem here for C. And at C, we have this. For each of the following limits, find the value or explain why it does not exist. And for me, I thought 1 and 3 were easy, and I got caught off guard by number 2. And I think it's still just the intuition from the graph, actually, that's pushing on me with regard to thinking they got number 2 wrong, because I'm pretty sure they didn't. But let's go through this. Okay. So this is going to be C. Is that on the camera? It is. Okay, C and then I. So if the function is continuous, so that one said for each of the following. So this is if the function is continuous, the function is continuous for x is greater than or equal to 5, because remember, we're doing the right side limit now. This is just the right side limit. As x is greater than or equal to 5, then, and it is because it's just a line, right? It's a line. Then the right side limit f of x plus h minus f. That was f of 5, because that's what we're doing, right? It's asking about that particular x minus f of 5 over h must exist. So that's the part 1 of it. It has to exist. And then it says find the value. All right, so how are you going to find this value? Well, I'll show you how I found it, and you can figure out how you want to find it. You might have a better way than me. I don't know. So the first thing we got to recognize is that even though it didn't give us a formula, I'm going to go back to the other one. There we go. Even though it didn't give us a formula for... We can't really figure out a formula for this. I mean, we could sort of try to wiggle out some sort of approximation, but who knows? This, however, they told us is what? They told us it's linear, right? And we have 2, well, we have 3, but we only need 2. If it's linear, it's a line. And so if we have 2 points, we can define the line, which means that we can get the formula for the line, and then we can actually take the derivative of that, right? And that's why we know it. That's why the answer is already yes. And now we actually have to do the derivative, though. Okay, so here we go. So the first thing we want to do is get the slope of the line, right? The slope of the line is delta y over delta x. And if you find a faster way, a better way to do this, you by all means tell me. And then so we have f of 6. Is that right? F of 6. Let me see. Well, it doesn't matter, right? You could do f of 6 or f of 5.5. I chose f of 6 because it's going to leave you with a 1 on the bottom, which just sort of saves you time, right? F of 6 minus f of 5 over 6 minus 5. So whatever that is, that's going to be over 1. So that's going to just save us a little bit. And f of 6 is 1.25, and f of 5 is 1. So we end up with 0.25 over 1, which is just the same thing as 1/4, right? All right, so now we have, we're going to try and figure out what is going on here in terms of the actual line. So our basic equation here is going to be 0.25 x plus b. And now we got to find, oops, I wrote 5. That's supposed to be a b. All right, that's not a b either. Okay, you know what, forget it. Y equals 0.25 x plus b. And that works for a line, right? And we know it works because it's a line. So, but now we have to find out what b is, right? So we know it's a line. We can stick any x and y we want in there and then solve for that. In this case, we're going to put in 1. 0.25, we're using f of 1, by the way. 0.25 times 5. F of 5 is 1 plus b, right? So then we get 1 equals 1.25, plus b. And then we do our last little bit of math, subtract 1.25 from both sides. We get negative 0.25 equals b. So now we have the equation for this line. Y equals 0.25x minus 0.25. All right, so we've done that part. Now, all right, so here we go. I hope I left myself enough room here. So we're going to take that y back out and put f of x in there. So we're going to have f of x equals 0.25x minus 0.25, right? Okay, you with me there? That's what f of x equals now. We've got a different formula in there. So now we can say that f of x plus h, that's what we're trying to figure out, because we need to deal with that h and see if that's going to go away, which it is in a minute. It's going to be 0.25 x plus h minus 0.25, right? You with me there? That's pretty easy, right? Simple math. All right, so then we're going to have f of x plus h equals, and then we're going to distribute that 0.25. 0.25x plus 0.25h minus 0.25. All right? Everybody good there? Now, we got to go back up into this thing and run it through there. We know f of x, and we know f of x plus h, right? So we're just going to substitute what we know here for these two things on our little limit thing. So the f of x plus h part is going to be 0.25x plus 0.25h minus 0.25. And then we're going to have minus, right, because it's minus f of x up there. And f of x is 0.25x minus 0.25. That's our f of x equation that we figured out over here from a slope, right? Over h. Now we're going to have to, we got 2 more steps. We're going to get rid of this parentheses. So that's going to be, I'm just going to have to rewrite this whole thing. 0.25h minus 0.25 minus 0.25x. And then minus a minus is plus 0.25, right? All over h. Now we're going to combine like terms. And actually what's going to happen, you know what's going to happen. Most of them are going to disappear, aren't they? There's a 0.25x and a negative 0.25x. So those disappear. There's a negative 0.25 and a positive 0.25. So those disappear. And we are left with 0.25h over h. And guess what cancels out there? This was a long time ago that we did this. So the answer is 0.25 or 1/4. That's the answer to, where are we? That's the answer to CI. That's the first one. I forgot to label that. Oh, I put the I down and then I made if out of it. I am the supreme goofball. So that's the first one. Now the second one, and you're going to see why we don't need room for this in a second. The second one, they say, does not exist. Where'd my notes go? Well, let's just look at it. It's the left side limit. And visually, the left side limit does exist, but what they are saying, in fact, you know what, I'm just going to open up the, I'm going to switch over there and I'm going to open up the actual answer thing for you here, because I just want to show you their thing, because they're all experts, and who am I to disagree with the experts? But anyway, here we go. Okay, so it's the scoring guidelines. That's A, and then that's part B. That's what we were looking for in part B. X equals 2, right? So that equals 0. Part C, okay. Part C, we're looking for these three things. The limit, the right side limit, which we just did. It comes out to 1 1/4. The left side limit, it does not exist, it says, because the numerator approaches 3 as the denominator approaches 0. So they say the left side limit doesn't exist. And of course, I think most of you would have got this, that the limit as h approaches 0 doesn't exist because visually we can see the jump continuity. I'll be perfectly frank with you. I'm still looking at this, why they're saying the left side limit doesn't exist. And they're saying because the numerator approaches 3 as the denominator approaches 0. So that's the answer there. And I'm going to have to dig deeper, and I will, to find out the answer to that. Okay, so that is the first one. Now let's go to the second one. All right, I did the problem, and I got a number that was really close, within 300ths, but it wasn't the number they were looking for, so I had to go back over and find out why. So I thought it would be instructive to show you that. So let me go back over here, and we'll start from the beginning because I just clipped out. I didn't want you to sit through everything that was wrong. All right, so here's the two things they want. First, they want the what was the question again? They want the average rate of change from 5 to 60, right, of the wind speed. So there is our equation for the wind chill, based as a factor of the wind speed. And so they want to know what the average rate of change is, right? So that's just the slope, the average slope over the whole thing. So 60 minus 5, because that's what we have, is the interval between 5 and 60. And then W of 60 minus W of 5. So we put 60 and 5 into that equation, and we get those numbers. And I'm going to tell you right now, based on what happened down here, make sure you use at least 4 decimal places wherever you can, because it's going to drift off. That's what happened to me. I didn't use quite enough decimal places, and I drifted off by 300ths. and I'd hate to lose a whole point just because I didn't bother sticking an extra decimal place in my calculator. So that is the average rate of change. So that's the average increase in wind chill per increase in mile per hour, right? Now they want to know when the instantaneous rate of change of the wind chill is equal to the average rate of change. So the instantaneous rate of change is, of course, the derivative. As soon as you hear instantaneous rate of change, all the derivative bells should be going off in your head. And so we have to take the derivative of this little formula, right? So, and that's not too bad. So we got W of V, right? And then W prime of V. This goes away altogether. We're going to, I know the way we shortcut it is that we take this and multiply it by that and then subtract 1 from this. But the long form way, I'm just doing it so you can see it, is we move this out front and then we stick that down there and then subtract 1 from it. And so 0.16 minus 1 is negative 0.84. And we have that 0.16 and we put it out there and we've just got that coefficient out there on front. We multiply 22.1 times 0.16 to get 3.54, which is where I should have kept more decimal places if I wanted to get the right answer. 3.536 would have done it. And again, 3.536 right there. And our V, and then we've got that. So once we've taken our derivative, and we want to find out where our derivative equals the instantaneous rate of change equals the average rate of change. So we set our derivative equal to the average rate of change, and we'll find out the instantaneous point at which the rate of change equals the average rate of change over the whole formula. So we got this, right? That's pretty simple now. Now we divide both sides by 3.536 instead of 3.54. And you can see that's almost as far away from 3.54 as you can get. It's not like 3.539. So a little drift, is not actually unreasonable to even notice intuitively. So that's what I got before. When I did it with the new numbers, instead of 0.07169, I got 0.07177 by keeping more decimal places. So that's going to be a big difference, especially as we start to get through here. A big difference. It's going to be like 3/100ths difference. But it's the difference between right and wrong, right? Or a point and not a point. So we got this. And how do we get rid? We want to get V by itself, and we have this exponent. So we're going to take this whole thing to another exponent, because when you take an exponent to an exponent, you just multiply the two exponents. And what do we do to get 1 out of this? We multiply by its reciprocal, right? So we take this whole business to the 1 over negative 0.84 power. And when you multiply that times that all disappears and becomes 1, right? And then you got to take, instead of this, you got to take this one to the 1 over, because you got to do the same thing to both sides, to the 1 over negative 0.84 power. And instead of 23.04, we get 23.01, which is actually the right answer by the book. So that is the walkthrough on that. And so I'm looking at this thinking, if I was doing this all over again, I would probably keep 4 decimals. And I don't know how you know that, except just to decide to keep a lot of accuracy wherever you can. I started out sticking with 2, right? Because we only have 2 decimal places up there, but that's an exponent. So it's probably not the best place to determine how many decimal places you need. Here we have 3 significant digits. So I probably should, well, I did stick with 3 significant digits. What can I say? If you got 3 significant digits there, you probably ought to stick with 4 or 5 for your intermediate calculations, right? And certainly this formula returns plenty of digits. And you can see that it introduced significant drift because I was 3/100ths off. So anyway, that's the walkthrough for that.